Hello, this is Dr. Phil Rosenkrantz again with EGR 403 Online. We're at presentation number 15, which is covering chapter 12 from our text. The topic is replacement and replacement analysis. Let's go to slide number 2 and take a look at our big picture. We can see that we're at the end of this slide with replacement analysis. We're going to look at a twist or a refinement to what we've been doing so far, and try and present to you some material that's probably going to be very useful, and it builds on everything we've done so far. And I'm not going to get into as much depth as I could with this, but at least you'll be exposed to it. And so if you need to get into more depth, you can go to other books and other methods. Let's go to slide number 3. What is replacement analysis? In the past, what we've talked about are how to compare two alternatives that basically are things we're planning on doing. For example, should we buy machine A or machine B? Now we're going to look at the situation where we already have one product or process or piece of equipment in place, and it's working, it's doing the job, but we're trying to decide whether it's time to replace it or not. And so this involves questions such as, when should a new truck replace the existing truck? When should a process be redesigned? Or when should a product be redesigned? And it turns out that this is a very common type of economic analysis issue. Let's go to slide number 4. When talking about replacement, it helps us to define the current equipment or process as the defender, and the proposed replacement that we're considering as the challenger. So let's go to slide number 5. Look at some of the aspects of replacement analysis. We have to use available data to determine which analysis technique we're going to use, and you'll see a table later on that kind of coordinates that. And what we're doing is looking at marginal costs and other costs to determine which alternative is preferred. When we do this kind of analysis, we have different challengers that we can consider, and what will be mentioned later on is that before we even do a comparison to our defender, we might have to narrow down our field of challengers to the best challenger. But again, as it will be pointed out later on, we don't necessarily know what the future holds for new challengers, so we're just working with the ones that we have available. Let's go to slide number 6. The replacement problem itself. Engineers replace the existing due to obsolescence, depletion, or deterioration. And the little box there, it has the big question. Shall the defender be replaced now or be maintained for one or more periods? And that is the real important issue with replacement analysis. When you're trying to decide whether you're going to replace the current piece of equipment or not, the decision you are really making is, am I going to replace it now or later? You're not deciding when to replace it in the future. The reason is because things change. You're making your decision for the moment, and then 6 months, a year, or whatever in the future, you'll reevaluate and make that decision based on what's available at that time. Let's go to slide number 7. This slide and the next 2 slides following are a list of issues to consider before starting. I'm not going to go over all of these bullets, but I'm going to pick a couple of them to go over. But I wanted to leave them here for you to go back and look at because they may help you in the future. On slide number 7, the one we're on, the first question is it morally or ethically right to do this project? What that's basically asking is to look at what are the consequences of doing this project. Who is affected now and in the future? How are they affected? How is society affected? because you may have a project that when you look at it from that standpoint, it may not be something you really should be doing. But that's probably the number one question. Going to slide number 8 and looking at the last bullet, it says, is preventative maintenance included in the model? I think you'll find that total preventative maintenance is something that's very popular these days, and many companies are looking at preventative maintenance as a very cost-effective approach to dealing with their production equipment, and so you might want to ask if that's included. Let's go to slide number 9. The first bullet, it says, are periodic operating and maintenance costs constant or variable over time? That's a big issue. Usually as equipment gets older, it costs more to maintain and to operate. But there are also costs for overhauling, and sometimes overhauling costs can be variable from the standpoint you can have a minor overhaul or a major overhaul. So you might want to explore those kinds of things when you're gathering your data. And the last bullet on slide number 9 says, are cash flow estimates deterministic or stochastic? And what that word stochastic means is there random variation in the costs that you're looking at? If you want to include a probabilistic approach in your model, you can. That's not covered in our book, but in advanced books on engineering economics, you can find methodologies for covering random variation. Let's go to slide number 10, replacement analysis decision chart. There's basically 3 analysis techniques being promoted in Chapter 12, and they're based on the kind of information that's available for the defender. It's assuming that you have information available for the challenger in terms of your estimates of its costs and initial costs and the costs for maintenance and operating in the future. We don't necessarily have that for the defender in all cases. So you can see that in analysis technique number 1, it says defender marginal cost, if that's available, and if it's increasing, then we would compare the defender's next year marginal cost to the EUAC at minimum cost life for the best challenger. Now, you don't understand what these mean just yet, but this table is a guide to how to go about doing replacement analysis. Let me say that what I'm going to concentrate on in this presentation is analysis technique number 2, because that involves finding the EUAC at minimum cost life for both the defender and the challenger. That's going to be, I think, the primary method that you might be using. So I'll move on for now, and I think that when we're done, you'd be able to go back to this table and it'd make a lot more sense. Going to slide number 11, what is the basic comparison? Well, like it was mentioned before, we're going to identify the defender and compare it to the best challenger. So we have to go through a process of finding the best challenger first. The decision criteria leads to one of the following, and I'm repeating this, but I'm doing it for emphasis. If the defender is more economical, it should be retained. If the challenger is more economical, it should be installed. And that's based on what we're doing right now, not in the future. Going to slide number 12. Now let's figure out how to calculate the minimum cost life for the challenger and essentially for the defender as well. What we're going to do is we're going to calculate the equivalent uniform annual cost for each value of the useful life. In other words, for a 1-year useful life, a 2-year, a 3-year, we're going to calculate an EUAC for each useful life. Then, the number of years of useful life that has the minimum EUAC gives us what we call the minimum cost life and the minimum cost EUAC. And we're going to use those numbers in our analysis technique. So let's look at an example, 12-1 from your book. We've got a piece of equipment with a $7,500 cost, a $900 arithmetic gradient for maintenance. In other words, as this piece of equipment gets older, the annual maintenance cost is going up by $900 a year. And then it's got a $500 uniform cost and a $400 arithmetic gradient for operating. So it starts out at $500 a year for operating costs, and then it goes up $400 a year on top of that thereafter. Let's go to slide number 13. Let's take a look at this. This is where we're calculating the EUAC for each value of n. And so let's look at the highlighted year, year number 4. And what we see there in the first column is the EUAC of capital recovery. That is the equivalent uniform annual cost of the $7,500 initial investment. So the $7,500 has been multiplied by the A over P factor for 4 years to get that. And so that shows what a 4-year life, how that $7,500 would be spread over at the minimum attractive rate of return. The next column is the EUAC of the maintenance and repair costs. So that's the EUAC of the gradient. So the gradient times the G over A factor gives us, the A over G factor gives us that number. Then the next column is the EUAC of the operating costs. So it's the 500 plus the uniform series that's equivalent to a $400 arithmetic gradient. So we've got the EUACs of all of our costs, and if we add those up, we get the total EUAC. And if you'll notice that that year 4 has the lowest EUAC. So if you purchased that piece of equipment, kept it for 4 years, and then replaced it after 4 years, and you did that over and over again for 4 years, every 4 years, you would have the minimum overall cost. That's the cost that balances out the initial cost with rising operating costs. Well, let's go to slide number 14. Sometimes the graphical look at this same data really drives the point home. If you look at each of the years along the x-axis, it shows the individual values for each of the 3 types of costs, the EUACs, and then the total EUAC. So the top curve shows you the EUAC after adding up each of the components. And you'll notice that at year 4, that's where that EUAC curve dips to its lowest point. And so that year is the economic useful life, and the total EUAC is the minimum cost EUAC. And these are the numbers we're going to use to compare this alternative to any competitors. Right, so that's the EUAC approach, minimum EUAC approach. This is the most important technique for you to learn from this chapter. Let's go to slide number 15. Marginal costs are a little different than the EUACs. They are the year-by-year costs for keeping an asset. And example 12.2 illustrates this. The marginal cost includes the loss in value of the asset by retaining it for 1 more year, any lost interest in the money that was tied up in the asset, and then costs and expenses directly related to the project or asset during that year, such as insurance or operating and maintenance cost. Let's go to slide number 16 and look at some numbers. Here we have a piece of equipment that initially cost $25,000, and then its value, its market value, goes down each year as it gets older. There's some overhead and maintenance costs given, an annual insurance cost given, and useful life and MARR. So let's look at the line that's highlighted in the lower table, and you'll see that the market value dropped in the first year from $25,000 to $18,000. So our loss in market value was $7,000. So we're going to put that into our marginal cost. We tied up $25,000 worth of capital in this piece of equipment its first year. So we gave away, or we could have earned, at 15%, we could have earned $3,750 on that money. Our operating and maintenance cost was $2,000, and our insurance cost is $5,000. So if we add up the loss in market value, foregone interest, overhead and maintenance, or operating and maintenance cost, insurance cost, that's $17,750, and that's called the marginal cost. So that was the cost of having that piece of equipment that year. And marginal costs can be compared in using some of our analysis techniques. Now, the marginal cost data for the Defender is shown on slide number 17. Let's go to slide number 17. What you need to understand whenever you're trying to come up with an EUAC or a marginal cost for the Defender, what you use for its initial cost is not what you paid for it when you initially purchased it. What you use in that column is its current market value. If you can sell that piece of equipment on the market as used equipment for example, $14,000, then that is the market value you use, and for year one in this case. You use it for the present value if you're doing EUAC analysis. It doesn't matter how much you spent for it originally. That was a sunk cost. It's what its current market value is what we use for the present value for economic analysis. Suppose the piece of equipment has a value of 0. Well, then that's what you use. If it has a market value of $14,000, then what that's saying is that if you that you're foregoing $14,000 by not selling it. Okay, I hope that wasn't too confusing. You can see the rest of the calculations there to get the total marginal cost. Let's go to slide number 18. The replacement analysis technique number 1. And this is what we use when Defender marginal costs are increasing. Then we replace when the marginal cost of ownership of the Defender is more than the EUAC of the Challenger. So that kind of makes sense, doesn't it? And if the EUAC of the Challenger is going to be lower than what we just spent on our Defender, and the Defender's costs are going up, then it's obviously time to replace. Let's go to slide number 19. The analysis technique number 1 is appropriate when replacement or repeatability assumptions hold, and that it also assumes that we have the best Challenger that's available in all subsequent years, and the period of needed service is infinitely long. And these are a little restrictive assumptions. You can relax those assumptions a little bit. Slide number 20, relaxed them by saying the best Challenger is available in subsequent years at the same economic cost, and the project life is known and limited. But anyway, analysis technique number 1 is pretty, I think, clear, but the one we're going to use the most is technique number 2. And so let's go to slide number 21. Here, if we assume repeatability, then we're going to compare the EUAC of the Defender at its minimum cost life against the EUAC of the Challenger at its minimum cost life. So the assumption of repeatability makes sense here because we're talking about looking, as far ahead into the future as we want. So we're just basically making a decision based on EUAC, minimum EUAC. So you find the lowest point in both curves for the Defender and the Challenger, and that's what you're comparing. Let's move to slide number 22, replacement analysis technique number 3. And here we have the decreasing value of the marginal cost. Compare the EUAC of the Defender over its stated life against the minimum EUAC of the Challenger. And it says here, defining the Defender and the Challenger first costs can be an issue. Again, we're working with market value. Let's go to slide number 23. The final comment is that what we've talked so far about didn't include taxes, and you can do after-tax replacement analysis, and by including some of the things that we've done in the past, by including depreciation, taxes, and some of the treatment of selling the item in terms of capital gains, take that into account. So you can add that to your analysis if you want. Anyway, I'm going to stop now, and hopefully you got enough out of this that you can be able to go back into the chapter and work the problem or problems that are assigned and understand these various analysis techniques. Thank you. Goodbye.